Hi, this is Dr. Thompson from Taylor University, and I'm going to give you an introduction to the technique of w-substitution for integration. So this integral is the integrand being x times cosine of x squared dx. And so this is a bit trickier than other antiderivatives you might have done earlier on in Calculus 1 because integration does not have a product rule or a quotient rule or a chain rule. And here you can see we've got a product x times cosine of x squared. So we also have a composition, which normally when you do derivatives, that requires the chain rule. And so this idea of w substitution is a way to do the chain rule backwards. So let's look at how that might work. So when we move to this next step here, we see that I'm just going to make a substitution of w being x squared. And my goal there is that I don't know how to do compositions. I'm going to focus on that part first. So I would like for this to be cosine of w. And so let's go ahead and make that change. Now here you see I've made that change, but the integral is not done yet. I cannot take this antiderivative primarily because I have two different variables. If I have dx being the differential, I'm integrating with respect to x, not w. And so right now having x and w, that basically looks like mumbo jumbo at this point. And so our next step is to change that differential. If we want to make a substitution and use this new variable w, we would like to integrate with respect to w. So I would like for dx to change to dw. And the way you do that is just to take the derivative. What you want to think about is that equation that you've made, that substitution of w equals x squared, that's a normal equation. I could graph that. It's a parabola. It has a derivative. So if I take the derivative with respect to x, I get dw equals 2x dx. I've already split the differential just to save time because this is how it's always going to happen with w substitution. Normally you might write dw over dx equals 2x, but the next thing you'll do is move the dx to the right side. And so that's a common way to write this step. And the point of this step is that now dx is right here as part of our equation, and I would like to solve for dx. So let's do that next. So in this step you see that I've solved for dx by dividing by 2x. So dx is equal to dw over 2x. This is great for several reasons. One, I can eliminate this dx in the integrand. I can also bring in dw, which I need. And this x I'm going to divide by, I think, might actually be useful. So let's see. So on this next slide, I'm just going to swap exactly this right side of this equation here, the dw over 2x. I'm going to swap that with the differential dx on the end. So here you see I've made the swap. I have dw over 2x instead of dx. And now I'm almost done. I have cosine of w, which I wanted. I have a dw, which means I'm integrating with the right variable. And I still have x, but now I think I can cancel. So on this step, we just went ahead and crossed out the x's, and now I have something that is entirely in terms of w, including the differential, and so it's an antiderivative I hopefully already know. The point of w substitution is to change the variable to simplify the integral into one that you can already do. So when you look at this step, I just took the 2 that was in the denominator and brought that out as a 1/2 outside the integral. So we're just going to multiply our answer by 1/2. And now our integrand is just cosine of w dw, which is something that we can do. So the antiderivative here will be 1/2 sine of w plus c. Can't forget that. However, we're not quite done. That is an answer to the antiderivative. However, it is not in our original variable. We took an antiderivative originally with respect to x, so we should change that. You have to remember originally that we made w equal to x squared, so we should change back our final answer, and so our final answer should be 1/2 sine of x squared plus c, not sine of w. And now one last thing to do is to check our answer. So the simplest way to check your answer when you do an antiderivative is to take the derivative and check that it works. And it also should give you a bit of intuition about why w substitution connects to the chain rule. So if we take the derivative of our answer, we have 1/2, sine becomes cosine, and because it's a chain rule, x squared stays where it is, but its derivative, 2x, is what you multiply by here for the chain rule. And of course, the plus c becomes a plus 0. If I simplify the 1/2 and the 2, and I bring the x out front, I get x cosine of x squared right there in the corner, which was our original integrand. So we did find the correct antiderivative. And that is our first example of doing w substitution.